We now have to move on and look at a little bit more complicated quadratic functions. So the very most basic quadratic function is in the form y equals a number times the x squared and nothing else. We're going to complicate it a little, and as you can see here, we're going to add on what we call a constant. Now, a constant is something that can't change. That's a number. You know that x is not constant. X keeps changing. But a number, for example, like 3 or 1 or -2, they never change. 3 is always 3, no matter what's happening to x or y, 3 is always 3. So in an equation, the number sitting by itself with no x on it is referred to as a constant. We're just going to investigate the impact of something, of a constant, on the simple x squared graph. So we need to fill out our table of values, and we're using the equation, I won't write it there, might get in the way. Y is equal to x squared plus 3. Now, hopefully you can see that that's just our x squared. And when we had x was -3, for our x squared bit, we had a 9. Now we've got to add on 3, and 9 and 3 is 12. So it's up at 12. When x was -2, our x squared bit was 4. And go back and check in the table if you're unsure. And 4 plus 3 is 7. And when x was -1, we had a +1. So y will be x squared, which is +1, plus 3, which is 4. And when x is 0, we're not at y is 0 this time, because we've got to add on 3. We're up at y is 3. So it's not going to go through the origin. The vertex won't be on the origin. Now that's an important feature to realise. At x is 1, x squared is 1 plus 3 is 4, and you can probably see that the pattern is going to be similar to the previous pattern in that this graph is also what we call symmetrical, and what happens on the negative side of the y-axis is repeated on the positive side of the y-axis. And so I've made an attempt to graph that, and again, it's not a nice smooth graph, but hopefully you'll get the idea. So again, we compare this graph to y equals x squared, and we make some observations. So compared to y equals x squared, all the y values are 3 units higher. Remember when we were here at the vertex, we were down 3 units. Over here at x is 1, we were only up 1 unit, whereas now we're up 4. So it's gone up 3 units. So the impact of that +3 is it has pushed the whole graph up 3 units. So adding a constant like 3 has the effect of moving the parabola up the y-axis for 3 units. Let's have a look now. We're in the same family. We've got the x squared plus 1, so we're still in this same category. We're adding on a constant. Though you've got to pay attention to all the detail and think about the impact of every aspect of the equation now. That negative is going to have an impact on the equation. It's going to turn the parabola upside down, and this +1 is going to push the parabola up 1 unit. Now this is all compared to y equals x squared. So we're comparing the impact of these changes to the graph of just y equals x squared. Now I've paused the video and completed this table of values for this new function minus x squared plus 1. If you're having trouble understanding where those numbers are from, please pause the video and go through the process of writing x is minus 3, y equals, it's minus x squared plus 1. So it's minus, the x is minus 3, that has to be squared, and you add 1. Remember, we looked at negative 3 squared at the very beginning. We know it's 9, but we must minus it because of this minus here. And then we're going to add 1, and minus 9 add 1, take your calculator if you need to, is minus 8. And that's where the minus 8 comes from. Like I said, if you're having trouble understanding where the minus 3, the 0, the 1 came from, you need to go through that process for each value of x. Now I'll leave that to you to decide if you need to do that. What I'm going to do now is to actually graph these new points. So at negative 3, we need to be down at negative 8. So we're here. At an x is negative 2, we need to be down at negative 3. And at x is negative 1, we're right on the axis. Y is 0. And at 0, we're up here at 1. No, I'm sorry. Yes, we're at 1. And at 1, we're back to 0. And 2, we're down at negative 3. And at 3, we're back down to negative 8. And I'll attempt to draw that. Oh, that's not very accurate. It's a bit better. It's not great. I'm sure you're getting the idea. So what's been the impact of these changes to the simple y equals x squared? The negative turned it upside down, and the plus 1, similar to what happened here. When we added 3, it pushed it up 3. When we added 1, we can see we've pushed the graph up 1. Our third example that we're going to look at in this same format of impacting with a constant is to subtract the constant. So the example I've chosen is y is equal to 2x squared subtract 1. Now, we have really already established what the impact is on adding 1, pushing it up. Hopefully you can see that subtracting 1 will push it down. And when you've filled out your table of values here and you graph it above, you will see that your parabola has been pushed down. But we've got an additional number that's going to impact on the graph, this 2 at the front. We saw that, however, back in the very first video, that the second video, the impact of the 2 makes the graph skinnier because 2 is bigger than 1. Putting a number bigger than 1 in front of the x squared makes the graph thinner, skinnier. So we should see something skinnier than x squared and being pushed down. Now I've been through and filled that out, and just like I explained how you got the values for this table up there, you'll do the same here. If you're unsure, you will put x equal, you'll say when x is minus 3, y is 2 times minus 3 squared minus 1. You must do the power first. Squaring any number makes a positive, and subtract 1. 2 nines are 18, subtract 1 is 17. If you need, you can go through those same steps and show that these are the values you get. Now, I've actually said here, I'm going to draw this graph up above in red. So let's go back. I've done that. I've plotted those points. And yeah, we've got a thinner looking parabola happening. That's because of the 2 in front of the x squared. And being pushed down 1 unit pushes it below the x-axis, just 1 unit. So we can see that subtracting a constant c moves the curve down the y-axis, and overall the effect of adding to or subtracting a number will move the graph. So if we add it, the graph goes up, or if we subtract it, the graph goes down the y-axis. I'm going to demonstrate a couple of general equations and their graphs, and I'll do that in this table in another video.